What is health? You got the old med school definition. Health is the absence of disease, which sounds like crap to me. And then you got the WHO saying health is well-being, which is a stupid thing to say, because now you gotta ask, what is well-being? I'm thinking of it different. I think health is the capacity to heal. And that means it can only be observed under stress or injury. Health is the action between two states. It is not a state itself. We think about a health state, and I think that's wrong. Health is about the velocity, not the position. It is the movement between two states rather than the location of one state. This means health is much more like a verb than it is a noun. Health is the capacity to heal. It is the movement between a state of distress and a restoration, a state of recovery. If that's true, or at least helpful, then you could only observe health in this transition between one state of stress and another state of recovery. When we measure VO2 max, we only observe it under stress. When we measure glucose spikes or insulin sensitivity, we only measure it under stress. What if health were like that? What if health were the verb, the action between two states that could only be observed during the movement from one to the other? How would that change the way you think about your health? I want to talk about how you do your own research on the internet. Because this morning I went to Google and I searched ice bath testosterone. And a couple of my articles showed up right there, number 1 and number 2. But something else happened. Google's AI summary engine said there is no evidence that an ice bath will boost testosterone levels. And that phrase, there is no evidence, reminds me of some of the same messages that were sent out during the COVID lockdown censorship of scientific information. And it bothered me because evidently Google's AI engine hasn't talked with Pamela Butler, who experienced a 10x increase in her testosterone after starting a regular program of ice baths. Evidently, Google's AI engine hasn't talked with Jeff Dobney, who had a client boost his testosterone almost 3 times in less than 30 days. Evidently, Google's AI engine hasn't talked to Sean Smiley, who recovered from an injured testicle and low testosterone levels by using ice baths. And Google definitely hasn't been paying attention to the Sakamoto study that showed if you exercise after your ice bath, as a man, it can boost your testosterone levels. This whole idea of there is no evidence evidently hasn't been cross-checked with Eloise DeSouter, who almost doubled her testosterone levels after starting a program of ice baths. I get text messages from people all over the world telling me that ice baths and exercise have boosted their T levels. And not just because of the exercise. Women don't even need to exercise. Women experience an immediate boost in salivary testosterone as a result of cold stimulation. And you don't have to take my word for it. Google's AI engine doesn't have to take my word for it. They can go and look at the clinical studies. When you're doing your own research on the internet, it's a great place to listen to those people who say, this is what happened to me. And it's a great place to find summaries of those clinical trials, of those case studies, of that explain, that document what has happened to others. It is not a great place to use AI summary search engines that have an agenda of their own. This morning, I got another one of those messages from a Twitter medical doctor saying, I checked your tweet with Grok, and Grok says you're wrong. These large language AI models, they are averaging engines. They're going to scan the entirety of Reddit and tell you the average of what's on the internet about whatever it is you're asking them. They're not going to give you the leading edge. They're not going to give you the most provocative and interesting new hypotheses. Ask Grok if mitochondria are exported by healthy brown fat cells, travel through the bloodstream, and can be imported by damaged heart muscle tissue to repair their mitochondrial function. Because Grok is scanning thousands of papers. And when an important scientific misconception is on the cusp of being overturned, or there's some new discovery like cold that stimulates your brown fat to make UV light inside your cells, you think ChatGPT is going to live on the leading edge of science when it comes to health and wellness? It'll be years behind. The AI LLMs, they all take the lowest common denominator approach. There's nothing wrong with using them to discover the citations that might lead you in the right direction, but you cannot trust Grok to give you the new thing that overturns the previous misconception. And there are some misconceptions that are so persistent, despite evidence accumulating over decades, that even Grok and ChatGPT will perpetuate them. Fear is a reliable mechanism of control, and the allopathic medical system has mastered it. Oh, your cholesterol is a little high. You should take this statin or you're going to die. Oh, your blood pressure seems to be creeping up. We should put you on these pills or you might drop dead at any moment. It is fear that is the reliable mechanism of control. People in love are crazy. They do nutsy stuff. You can't control someone in love. You can only control people by putting them into fear. And it is fear that motivates parents to get their children vaccinated. It is fear that motivates people to take statins and to be over-medicated to their own demise. It is fear that causes people to smear poisonous sunscreen onto their skin to give themselves the very cancers that their dermatologists claim they're trying to prevent. It is fear that sells. There's a post going around about some Norwegian doctor who said that he looked at all of the strokes in his middle-aged male patients and found out that 74% of these Norwegian middle-aged men did cold showers. There's no control group. He doesn't say how often they cold showered. He doesn't say how many Norwegian middle-aged men who don't have strokes also do cold showers. Maybe it's 90%. We just don't know. The single most important contraindication to cold plunge therapy is hypertension. It is true that if you have chronic high blood pressure and you get into the ice bath will boost your blood pressure. Look, if you've got chronic hypertension, start with sauna instead of cold plunge. Get your high blood pressure down before you start climbing into the ice bath with chunks up to your neck. Also, cold showers are not the same as whole body cold water immersion. There's a study out of Finland that compared partial with whole body cold
and discovered that partial activates the sympathetic division of the central nervous system, but you never get that dive reflex, that parasympathetic response that lowers your heart rate, that brings your brain down into a meditative state. And so, for those with chronic hypertension, avoid cold showers. Start with sauna until you get that stuff under control. But don't be swayed by some fear-mongering made-up study out of some anonymous Norwegian doctor with no control that says, oh my gosh, you're gonna die if you cold shower. I'm up to maybe ice bath 3,000. And if you believed the rumors and popular misconceptions about cold plunge therapy, then you'd think I died a long time ago. Here I am.
Oxidative stress. It sounds terrible. Thomas DeLauer just did a video saying that he doesn't cold plunge as much anymore. He's cut back because he heard that it causes oxidative stress. Well, of course it does. Why would oxidative stress be a bad thing? It is the production of reactive oxygen species that stimulate mitobiogenesis. You know what else causes oxidative stress? Exercise. Oxidative stress is a normal, healthy, hormetic response to any stress. When you do it in an episode, like an acute, extreme, short ice bath, like I'm doing right now, you stress your mitochondria. They produce excess reactive oxygen species. That ROS stimulates both mitophagy and mitobiogenesis. In other words, the new production of healthy mitochondria, as long as you give your body a chance to rest, either from cold thermogenesis or rest from exercise. Then the hormetic oxidative stress makes you stronger. This is why we stress ourselves, so that we come back better.
It's been 25 years since President Bill Clinton first celebrated the release of the draft human genome, and it hasn't done a dang thing for the health of Americans since. It's because the genome is the wrong place to look. There's been a huge Silicon Valley venture capital technology gold rush into personalized medicine based upon the idea that most Americans carry some sort of rare genetic disorder that needs correction. And it doesn't make any sense. It is not the genome that governs your health. It is the epigenome that turns on or off the expression of your genes. And what controls the landscape of the epigenome? Your mitochondria. Mitochondria are life. Without the mitochondria, the human genome is inert. It is mitochondrial health with which we should be concerned. It is the mitochondria that sense your light environment. It is the mitochondria that sense the metabolites in your bloodstream that form the basis for production of ATP. And it is the mitochondria that control the landscape of the epigenome. The mitochondria that cause your genome to respond to your environment and prepare the DNA in your nucleus to adapt to the conditions to which you have been exposed. Stop thinking that you have some kind of genetic defect that you've got to pay some Silicon Valley guy money to correct, and start thinking about how to give your mitochondria the right stimulus to produce the energy that keeps you alive.
Life expectancy in the United States peaked about 10 years ago, which means that despite spending more money per capita than any other country in the world on health care and health research, we've been going backwards in the United States on quality of health. The reason for it isn't terribly complicated. It is insulin resistance. All the leading causes of death from chronic illness originate in mitochondrial dysfunction. It is the mitochondria that convert the lipids and the glucose in your bloodstream into the usable forms of energy that your cells need. And when the mitochondria become damaged, your body responds with insulin resistance. That is, slowing the flow of glucose from the bloodstream into the cell for conversion by the mitochondria. It is mitochondrial dysfunction that it is at the root of type 2 diabetes, Alzheimer's, cardiovascular events, obesity, PCOS, and a host of other chronic ailments that we ordinarily associate with aging, but are really a function of mitochondrial damage. An ice bath modifies both glucose levels and ketone levels in the bloodstream, and it happens fast. So if you've eaten a little bit too much of that pumpkin pie and you're experiencing a glucose spike, you might be able to bring it back down just by getting in the cold. The first thing that happens is your liver senses the danger, the activation of the sympathetic nervous system, that fight or flight response. And to fuel your muscles in case you gotta run fast, your liver releases glycogen into your bloodstream. This raises blood glucose levels. And in a healthy, insulin-sensitive person, they could get up as high as 140. We've got some good CGM data on this. But it doesn't last for very long, because your brown fat is sucking that glucose out of the bloodstream and using it to fuel non-shivering thermogenesis. Because the glucose stores available both in the bloodstream and the liver are so short-lived, the brown fat is going to have to switch off of glucose and onto lipids, onto fats, and do it fast. So as soon as you get in and your sympathetic nervous system is activating your brown fat, white fat cells begin to release their fat stores into the bloodstream as well, so that that fat can take over, fueling the non-shivering thermogenesis in your brown fat as soon as the glucose is depleted. It'll take less than 2 minutes. The fastest way to stimulate endogenous ketone production is an ice bath. Because as part of that fat metabolism to create the heat of non-shivering thermogenesis in your brown fat, ketones are produced, and your brain loves ketones. You don't have to wait 3 days of zero carb dieting to produce endogenous ketones. You can do it when you get right into the ice bath. Your brain will use those ketones in your bloodstream first. It'll sharpen your cognition and improve your brain health, and it might get you into a state of ketosis or a ketogenic metabolic state faster than fasting alone. So one of the best ways to build your metabolic flexibility, that is, allowing your body to switch from glucose to fat metabolism back and forth readily is to practice ice baths, because once you've activated your brown fat, you're using both the glucose and the fat metabolic pathways at the same time.
Carnivore and keto are two different diets. You've probably heard Dr. Courtney Hunt talk about this many times, and I'm going to go over it again for two reasons. The first reason is because your dietitian, your nutritionist, even your endocrinologist do not understand this, and they won't be able to explain it to you. When my son was young, he was diagnosed with type 1 diabetes. We kept scrupulous records of everything that he ate, his exercise, and all of the insulin that we injected into his body. When I met with his pediatric endocrinologist and I showed that he was on a zero-carb diet, he might have a cheeseburger with no bun, no ketchup, no pickle for lunch. Several hours later, he would experience an increase in his blood glucose levels that required me to anticipate that and add more NPH or give him an additional dose of H insulin to compensate for it. The endocrinologist thought I was lying. He told me that protein will not increase blood glucose levels. And I had to go look it up for myself to discover that I needed a new endocrinologist. There is a process called gluconeogenesis, in which glucose is synthesized from amino acids. And you might know that amino acids are the building blocks of protein. So when your body takes in excess protein, breaks it down through digestion into amino acids, it provides the substrate from which new glucose can be synthesized and added to your bloodstream. But that doesn't explain why your body would do this. You probably know that the brain uses glucose unless ketones are available. The brain prefers ketones for fuel, in the sense that when ketones are available, they will always be metabolized in the brain. But the brain can't run on ketones exclusively. And this is the second reason why I bring up the difference between the carnivore and the ketogenic diet. Professor Stephen Cunnane, he taught me that glucose is not just a fuel inside the brain. It is also a material feedstock for the production of GABA. GABA is a neurotransmitter that is important in regulating mood. The brain will never abandon glucose, because if the glucose is in short supply, or if insulin resistance prevents the glucose from entering the cells, it will be incapable of producing materials like GABA that the brain needs for healthy function. And so now we must understand that when a carnivore diet contains high levels of protein, it may support gluconeogenesis or neoglucogenesis to the extent where you never enter ketosis and your body is not making ketones, because it has all the feedstock it needs to continue burning glucose to fuel every process within the body. Ketones are a byproduct of fat metabolism, not protein metabolism. To enter ketosis, you must eat a diet that is not just low in carbohydrates, but also high enough in fat and low enough in protein that you switch your metabolism to fat burning and away from glucose.
You may have heard that ice baths are going to help you lose weight. There's a few stories online of people who've lost a lot of weight after they started a program of ice baths. And it is true that when you're submerged up to your neck in freezing water, you're gonna burn a lot of fat. There are continuous glucose monitors and continuous ketone monitors that suggest this is exactly the case. But I doubt that an ice bath is really gonna help you get ripped. And I'm an N=1 experiment to show that. I recently came back from the Optispan lab in Seattle, Washington. They performed a DEXA scan and an in-body scan, and I suspected that the two different values would be different. They weren't. I'm about 28% body fat, which is obese. If you know me, you might say, well, gosh, he doesn't look that obese. But I've got too much fat on my frame. But that doesn't mean that all of that fat comes with the metabolic dysfunction it is ordinarily associated with. Whereas the ice bath is not helping me lose weight, it is keeping me metabolically healthy. The difference is found in other aspects of my scan. They looked at my thyroid, they looked at my liver, they looked at my arteries to see if there was plaque buildup. And by all of these measures, with the exception of VO2 max, where I'm a pathetic 28, by all of the other measures, I am strong and metabolically healthy. How can this be? When obesity is the result of metabolic dysfunction, it will be associated with all of the symptoms of aging, of chronic illness, which we ordinarily think of come with obesity. But in my case, it is possible for someone like me to be metabolically healthy, that is sensitive to insulin, that is have excellent glucose management, even though I have more fat than would otherwise be considered healthy. I'm not sure what I'm going to do about this. I'm going to keep up with the ice baths, but I lead this sort of sedentary life of a college professor and a writer. I exercise a little bit after my ice bath, but I don't do any cardio. And you might say, well, if you're burning all that fat in the ice bath, how can you still be obese? In animal models, it turns out that compensatory metabolic mechanisms reduce the basal metabolic rate at night, lower your core body temperature, help you sleep better, and allow your body to restore the volume of white fat that has been burnt while you were cold. So will an ice bath help you lose weight? It might a little bit, by taking your inflammation down, by helping you lose some of the excess water associated with that inflammation. And the improvement in insulin sensitivity is likely to take a little bit off of your weight as well. But it is going to be no miracle weight loss cure. What it does instead is remodel the fat in your body. This is where ice baths can help. Even if your body composition doesn't improve that much, the ice baths, if you're anything like me, might help you improve your metabolism.
A calorie is a concept invented in the 19th century by French engineers trying to improve the performance of steam engines and make more money for the railroads. The word calorie has no place in a lexicon of human health, wellness, resilience, or performance. Ben Bickman is really good on this. He just appeared on the Diary of a CEO podcast, and he's told Stephen Bartlett that it is insulin that regulates fat cells within the body, not calories. Calories are a gross unit of energy. So they're great for steam engines. Think of calories as the size of the energy pie. But it has nothing to do with nutrition. It's not calories that dictate body composition. It's hormones that divide the size of that pie, that slice it up among the different components of the body. When insulin is high, it takes the calories and shoves them into the fat cells to grow fat. But what Bickman didn't mention was another hormone that controls the size of muscles. It's called myostatin. And when myostatin gets too high, it inhibits muscle growth. So high insulin means more fat. High myostatin means less muscle. To improve body composition, you must regulate insulin, keep it low to shrink fat, and myostatin, keep myostatin low to grow muscle. Now, what could somebody do that would both lower insulin and myostatin? Whole body cryotherapy. A 2021 study in the journal Nature measured insulin levels and myostatin levels in human subjects undergoing whole body cryotherapy and found that cold will reduce insulin, reduce myostatin, and thereby dictate the hormonal signals that control healthy body composition.
Cholesterol is essential for healthy human function. That's why your liver makes it. That's why people with higher levels of cholesterol tend to live longer, because your body needs cholesterol. Cholesterol is the substrate, for example, from which all sex hormones are synthesized. Testosterone, estradiol, all of your sex steroids, they originate inside your mitochondria, where an enzyme called P450 SCC is converted to pregnenolone. All the other sex hormones are downstream of pregnenolone. So you need cholesterol for healthy testosterone levels. And that's why low levels of cholesterol are associated with low levels of testosterone. If your doctor has you taken a statin to reduce your cholesterol levels, you might need to know that statins are also associated with lower levels of testosterone and consequently with muscle atrophy, because testosterone is a hormone that regulates body composition. Higher levels of testosterone are associated with more muscle mass and less fat. There is a feedback loop between body fat and testosterone. Your white fat will convert testosterone to estrogens, and that reduces your muscle composition and increases your fat, thereby turning the feedback loop of even lower testosterone. If you are worried about body composition, you must be worried about cholesterol, because high levels of cholesterol will support testosterone synthesis. And you're probably thinking, but what about heart disease? Maybe you're thinking, some internet doctor told me to watch my ApoB or my very fine LDL particle count. It's all a bunch of nonsense. It's not LDL cholesterol that is associated with heart disease. It's the glycation of LDL cholesterol. It is the combination of LDL cholesterol with glucose. When your body experiences glucose spikes from eating too many carbohydrates too fast, or from messing up your light environment,
glucose attaches itself to small LDL particles, and that's when it becomes dangerous for your cardiovascular system. Before you let your doctor prescribe for you a lifetime of testosterone replacement therapy, there are 3 things you need to know. The first is that all testosterone, all sex hormones, are synthesized from cholesterol. Maybe the reason your testosterone is low is because you've let your cholesterol get too low. When LDL and HDL get down into that lower 25th percentile of the range considered normal, it begins to inhibit sex hormone synthesis. The second thing that you need to know is that all sex hormone synthesis originates in the mitochondria. Your low testosterone might be the result of mitochondrial dysfunction. And how would you know? The earliest clinical marker of mitochondrial disorder is erectile dysfunction. It is the mitochondria that produce nitric oxide to dilate the blood vessels so that a man can maintain an erection. It is the mitochondria that synthesize, that are the site of pregnenolone synthesis, so that pregnenolone, which is a sex steroid, can then later be metabolized into testosterone. When your mitochondria aren't working right, then your sex hormone levels can't be right. And the third is, maybe you have everything on point, but you don't realize that your mitochondria need minerals. In particular, for testosterone, you need zinc and magnesium. You might feel healthy. You might be metabolically in good shape. Maybe you have high, healthy cholesterol. But if you're not getting enough magnesium and enough zinc in your diet to replenish that which your body is losing every day, then your mitochondria will be starving for the minerals they need to create enzymes for proper sex hormone synthesis. Before you begin a lifetime of taking steroids, consider that you might address the reasons that your testosterone is low in the first place. There are at least 4 routes to mitochondrial injury that will disrupt your metabolism. The first one is poor light hygiene. You need dark nights and bright days. The second one is too much seed oils in your diet. The seed oils, which are high in omega-6 fatty acids, get incorporated into the membranes of your cells and your mitochondria. And when they have too much omega-6 fatty acids in the phospholipids that make up your membranes, they disrupt the transport of nutrients and protons across the cell and mitochondrial membranes. The third way is too many carbs. The carbohydrates stimulate energy conversion in the mitochondria that produce reactive oxygen species. And that ROS can signal mitobiogenesis. When it is chronic and you never give the mitochondria a break from carbohydrates, the ROS will damage mitochondrial DNA. And the fourth route is environmental toxins. That could be microplastics, it could be heavy metals, it could be non-native EMFs that disrupt the mitochondrial function. To care for your metabolism, you must care for your mitochondria. Cold plunge is one of the best ways to stimulate mitobiogenesis and rejuvenate your mitochondria and fix your metabolism. There we go. There's something about seed oils that the internet isn't telling you. You've probably heard that seed oils have to be extracted from the seeds
with hexane. And that shouldn't really bother you. You've probably heard that seed oils from plants like cotton and canola have to be detoxified in a factory before they're made edible. That should probably bother you a little bit. And you've probably heard that Peter Attia is insulted when a chef puts seed oil free on the menu. And that shouldn't bother you in the least. But what you haven't heard is that seed oils interfere with the function of cell and mitochondrial membranes. Seed oils are particularly rich in what are called omega-6 fatty acids, which are different from omega-3 fatty acids. And the difference is in the position of a double bond in a hydrocarbon chain. If that bond is in the 3 position, it's omega-3. And if it's in the 6 position, it's omega-6. Because these fatty acids are incorporated into cell membranes in a molecule called phospholipids, they aren't burnt up for energy. Even though fats have high caloric density, your body will use them as material building blocks to create these cell and mitochondrial membranes. The molecules there function according to their structure. When you move the double bond from the 3 position to the 6 position, you're changing the structure of the phospholipid from which these membranes are formed. That change in the structure changes the performance of the membrane. Your mitochondria, which have 2 membranes, an outer and an inner, and your cells depend upon the healthy functioning of those phospholipid membranes. When you eat too many seed oils, you boost the omega-6 content of the membrane and diminish the omega-3. That altered function of the membrane changes the efficiency with which it is able to transport nutrients, and it interferes with the ability of the mitochondria to fuel respiration. I've always had a hard time explaining the health benefits of grounding. You've probably heard me say that putting yourself into electrical connection with the earth allows you to use electrons from the earth to rebalance the charge environment in your bloodstream. This reduces your blood viscosity. It reduces the extent to which the red blood cells will agglomerate or attach to one another, so that they can now fit through your capillaries and your micro blood vessels, improve perfusion, and improve the circulation of your blood. It's always what I've said about grounding, and it's true. But it's never convinced people that that is the mechanism of all the amazing health benefits associated with grounding. 2025, a new study came out of the University of California, Davis, and it looked at the function of mitochondria in grounded versus ungrounded conditions. And I don't know why I didn't think of this before, but they discovered that grounding improves the function of mitochondria. You get more ATP and fewer reactive oxygen species. You probably know that the whole point to mitochondria is to move electrons around. They do what's called respiration. They will take oxygen out of the bloodstream and use it as an electron acceptor to produce carbon dioxide and water from glucose or from fats. This is how they produce either ATP, which fuels all of the processes in the body, or heat in non-shivering thermogenesis. So the electron environment
of the mitochondria is very important to their function. And what these researchers at University of California, Davis measured was a change in the mitochondrial membrane potential under grounded conditions. The change was pretty small, 5 or 6%, they said. But the function of the mitochondria moves exponentially with respect to the membrane potential. And so ATP production went up something like 30%, and reactive oxygen species production went down a corresponding amount. That's important because a little bit of reactive oxygen species is good. It signals mitobiogenesis, but too much ROS will consume all of the melatonin and other protective factors inside the mitochondria and damage the mitochondrial DNA. In the short term, that's okay, as long as the mitochondria get a break and can recover. That stimulation of mitobiogenesis can be a hormetic stress, but under chronic mitochondrial stress, with no period of recovery, they accumulate ROS damage and their function degrades. Another word for that is aging. When you ground your mitochondria, you improve the efficiency of their function by increasing ATP, reducing ROS, and extending the life of the mitochondria that you've got. And that may be one of the most important mechanisms by which grounding has all of these wonderful health and mental health benefits.
Healthy mitochondria control the development of neurons in the brain. When the brain is developing in utero and after birth, it goes through periods of neural growth and connection, and then pruning. As many as 80% of these neural connections can be pruned in any single wave. And so the brain grows, prunes, grows, prunes. It is mitochondria that control that pruning process so that the connections between different neurons that are required for typical brain function are retained, and those that are not are eliminated. When the mitochondria are not healthy, when they are suffering from dysfunction or impairment during those critical phases of brain development, that pruning process does not necessarily go according to plan. And connections which should have been eliminated may be retained. The role of healthy mitochondria in the development of the brain during late-stage pregnancy in the first few years of life is critical to steer that neural developmental trajectory. And when it isn't typical, an immunological event like a fever, especially in response to a vaccine, or some other mitochondrial insult that causes inflammation in the brain, might trigger the onset of autism. Mitochondria make light called biophotons. They can't help it. The whole job of the mitochondria is to move electrons. When they're facilitating respiration, they take in the metabolic substrates, fats and glucose, that are made up of primarily carbon and hydrogen and some oxygen atoms. And then they combine that carbon and hydrogen with oxygen to make carbon dioxide and water. And this involves the movement of electrons. When those electrons move from one shell in one atom to another shell in another atom, they emit light. The light is so difficult to detect from outside the body that they're called ultra-weak biophotons. But inside the body, the light that the mitochondria emit is intense, when it's inside the cell. Now, ordinarily, most of the energy that the mitochondria are converting is used to produce ATP. And that ATP is then used elsewhere in the body for everything, growth, exercise, metabolism, wound healing, everything. But when the mitochondria are activated by cold to produce heat, most of the energy is going into light, not ATP. Your brown fat are the cells principally involved in what's called cold thermogenesis. Cold thermogenesis is your mitochondria using these metabolic substrates via respiration to produce heat, to defend your core body temperature against the cold. And when they do that, of course, the energy isn't going into producing ATP, it's going into producing light. Heat energy is thousands of nanometers in wavelength. But biophotons aren't just in those longer wavelengths. They're also produced in the shorter wavelengths, including UVB. When that UVB is emitted from mitochondria during cold thermogenesis, it will intersect a cholesterol molecule inside the brown fat, and when it does, it will convert that cholesterol to pre-vitamin D. Cold is how human beings can maintain healthy vitamin D levels despite the lack of sunshine during the winter.
Anticipatory thermogenesis describes a process in which your thoughts can activate your brown fat before you get into the cold water. It's a term that was coined by Dr. Tim Noakes from South Africa when he was supervising Lewis Pugh's cold water swimming sessions. He noticed that Pugh's core temperature went up before Pugh got into the cold water. And he hypothesized that it was Pugh's brain imagining the cold that activated his brown fat and began the process of non-shivering thermogenesis. This has been replicated in other subjects who are accustomed to cold plunge training or doing ice baths, and it's been documented in studies of Wim Hof. I got to meet Wim and talk to him for a few hours recently about this phenomena in which what we ordinarily consider involuntary or autonomic can become voluntary. If you have the power to activate your brown fat exclusively through your thoughts, I wonder what else you might be able to control.
I'm doing something a little different with my ice bath this morning. I read somewhere that ginger is thermogenic. That is, that ginger will activate brown fat and boost your metabolism by causing your brown fat to produce heat. There are several foods that do this, mostly the spicy ones, like peppers. So this morning, I sliced up some old ginger root, and I put it into a small pot of water with some cinnamon sticks. The cinnamon is to improve insulin sensitivity. I read somewhere else that cinnamon, which is part of the bark of a cinnamon tree, will increase insulin sensitivity. So I'm like, okay, I'll have some ginger for activating my brown fat. I'll have some cinnamon for improving my insulin sensitivity. And I'll see if that helps me in my ice bath.
Anticipatory thermogenesis describes a process in which your thoughts can activate your brown fat before you get into the cold water. It's a term that was coined by Dr. Tim Noakes from South Africa when he was supervising Lewis Pugh's cold water swimming sessions. He noticed that Pugh's core temperature went up before Pugh got into the cold water. And he hypothesized that it was Pugh's brain imagining the cold that activated his brown fat and began the process of non-shivering thermogenesis. This has been replicated in other subjects who are accustomed to cold plunge training or doing ice baths, and it's been documented in studies of Wim Hof. I got to meet Wim and talk to him for a few hours recently about this phenomena in which what we ordinarily consider involuntary or autonomic can become voluntary. If you have the power to activate your brown fat exclusively through your thoughts, I wonder what else you might be able to control.
Cold training is kind of like weight training. There's no one optimum time and temperature for an ice bath that applies to everybody. If you're just starting out, the rule of thumb is go cold enough to gasp and long enough to shiver. I don't know what temperature might correspond to your gasp reflex because it depends on how well your body has been acclimated to the cold before you start your practice. It's okay to be at 55, 50 degrees Fahrenheit. If that's where you get some gasp reflex, that's a good place to start. And when you're beginning, stay in long enough so that you feel the urge to shiver. That's how you know your thermoregulatory systems will be activated and your body will begin to recruit new brown fat. After a couple of weeks, you don't have to have the urge to shiver anymore, but you're probably going to have to step down your temperature to still get the gasp reflex. Just like in the gym, when you start working out, you get stronger, and so it makes sense to add more weight as you train. I talked to a guy the other day. He's at 49 degrees, and he feels pretty comfortable there. He told me, from what I've read, there really aren't any benefits to going lower. So he asked me, are there? I said, it depends on what you're going for. If you go to the gym and you do your workout, you're doing your 100-pound bench presses and you're really comfortable with where you are, you don't need to add weight and you wouldn't have to add cold. But are there benefits to being stronger? Are there benefits to getting that gasp reflex, putting yourself into discomfort, feeling the anticipatory anxiety of the ice chunks floating in the water, and the sense of cheating death and confidence that you get when you're able to structure your breathing in a freezing cold environment? For me, there are.